Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning. Alhamdulillah kita masih bertemu pada pagi hari ini untuk kuliah online ya. Ya, pekan lalu kita sudah melakukan evaluasi tengah semester ya. Dan ini belum sempat saya koreksi semua ya. Ya, cuma saya melihat sekilas ya, jadi skimming aja begitu. Ya, sebagian sudah betul, ya, sebagian masih banyak yang kurang tepat, gitu ya. Jadi kita akan bahas sedikit.
Bu, mohon maaf Bu, layarnya itu sebagian tidak terlihat Bu, yang bawah, samping kanan dan samping kiri.
Bawah sampai kanan, samping kiri. Oh gitu, mungkin ini ya agak kurang bagus dengan jaringan saya sebentar. Ini absennya
itu Bu, hitam warnanya Bu.
Hitam, coba sebentar.
Nggak kelihatan absennya Bu.
Oh gitu.
Iya.
Ya, ini sudah jelas belum? Sudah ya, baik.
Sudah Bu, terima kasih.
Jadi ini untuk S2 ya. Untuk S2 kodenya 363, maaf, sebentar. Ya, 363-209. Ini yang untuk S2. Ini yang untuk S3 ya, untuk S3 ini kodenya 314 317. Baik, ini kita akan bahas tugas ya. Ini kelihatannya Ahmed belum bergabung ya. Ahmed, Fiona juga belum ya. Kita akan coba bahas tugasnya sedikit ya. Baik, jadi ini adalah soal ETS kita kemarin ya. Yang mana di sini kita punya pompa ya yang mengalirkan ke pipa percabangan semacam ini. Ya, jadi di sini kita lihat setiap pipa ya mempunyai panjang dan diameter yang sama, dan di mana di sini sudah didapatkan persamaan seperti ini ya. Jadi ada Q1 sama dengan Q2 ditambah Q3 untuk persamaan pertama dan seterusnya. Nah, ini sudah diketahui ya, Q1-nya adalah 3 liter per menit. Jadi nilai Q1 ini sudah diketahui. Nah, sehingga dari sini artinya nanti kita diminta ya untuk menuliskan sistem yang diselesaikan ini dalam bentuk matriks, yaitu A, matriks koefisien A dikalikan dengan unknown Q itu adalah sama dengan B. Ya. Jadi unknown key ini adalah untuk variabel yang tidak diketahui. Untuk variabel yang tidak diketahui. Sehingga di sini apa variabel yang tidak diketahui? Di sini ada 5Q yang mana yang satu sudah diketahui. Berarti yang tidak diketahui ada 4 ya, yaitu dari Q2 sampai Q5 ya. Artinya nanti kita menyelesaikan 4 persamaan dengan 4 untuk menyelesaikan 4 yang tidak diketahui ya. Jadi menyelesaikan 4 persamaan untuk 4 Q yang tidak diketahui. Nah, setelah itu nanti kita diminta untuk mengerjakan ya. Mengerjakan menggunakan metode numerik apa saja ya. Boleh dengan iterasi ya, ataupun dengan metode numerical Gaussian elimination atau menggunakan Gauss-Jordan dan yang lainnya ya. Nah, di sini yang penting ya, kalau saya perhatikan ini ada beberapa yang salah di penulisan AQ sama dengan B di sini ya. Nah, jadi di penulisan AQ sama dengan B itu dituliskan ada 5 persamaan ya, jadi Q1 itu masih dimasukkan di situ. Nah, ini kurang tepat ya. Jadi seharusnya Q1 itu tidak masuk di dalam persamaan tersebut. Ya, jadi nanti hanya ada 4 saja. Ya, 4 yang tertulis di situ yaitu Q1 sama dengan Q2 ditambah dengan Q3. Nah, jadi nanti hanya ada 4 persamaan, 4 baris ya. Jadi matriksnya nanti 4 kali 4 ya. Itu adalah dimensi dari matriksnya. Ya, 4 kali 4 untuk menyelesaikan dari Q2 sampai Q5. Nah, itu yang pertama ya. Jadi yang saya perhatikan kemarin banyak yang memasukkan nilai Q1-nya. Jadi Q1 itu termasuk di dalam unknown di situ. Ya, jadi dituliskan 1 Q1 sama dengan 3 begitu. Nah, ini nantinya akan menyulitkan perhitungan. Jadi dimasukkan di dalam sistem hanya apa variabel yang belum diketahui. Kalau sudah diketahui maka tidak masuk di dalam vektor Q tersebut. Nah, kemudian disuruh menyelesaikan. Nah, ini menyelesaikannya bebas ya. Saya lihat kebanyakan menggunakan Gaussian elimination ya. Bisa dilakukan pivoting maupun tidak. Nah, tetapi ini harus diperhatikan bahwa yang diminta di sini adalah menyelesaikan secara numerik ya. Menyelesaikan secara numerik artinya menggunakan metode numerik yang kita sudah pelajari. Bagaimana dengan substitusi biasa ya? Dengan substitusi biasa maka itu tidak termasuk di dalam metode numerik. Nah, ini diperhatikan tolong ya. Jadi metode numerik di sini adalah segala sesuatu yang sudah kita pelajari kemarin metodenya. Kalau substitusi biasa ya, kalau substitusi biasa maka itu tidak masuk di dalam metode numerik ya. Itu penyelesaian secara analytical ya. Nah, jadi itu tolong diperhatikan ya. Nah, kemudian yang kedua, ya, yang kedua di sini diminta mencari ya nilai, ya diminta mencari nilai dari G ya gravitasi. Jadi ini diketahui percepatan gravitasi pada berbagai ketinggian. Ya. Nah, ini diminta pada ketinggian 55.000, sedangkan data yang kita miliki adalah dari 0, 30.000, 60.000, 90.000 sampai 120.000. Ya, sehingga di sini nanti kita perlu mencari pada 55.000, artinya posisinya ada di sini ya, 55.000 antara 30.000 ke 60.000 ya. Nah, diminta menggunakan metode numerik apa saja untuk mendapatkan keakuratan yang tertinggi. Nah, jadi kalau keakuratan tertinggi di sini artinya kita punya berapa poin? 1, 2, 3, 4, 5 ya. Jadi kita punya 5 poin. Berarti kalau 5 poin order berapa yang bisa kita dapatkan di situ? Dengan interpolasi ya, dengan interpolasi maka interpolasi order berapa yang bisa kita dapatkan yang tertinggi di situ?
4, Bu.
Ya.
Order 4, Bu.
Betul. Jadi sampai order pangkat 4. Ya, artinya kita mendapatkan persamaan pangkat 4 untuk interpolasinya. Ya. Dan ini kalau saya lihat ya, kebanyakan menggunakan metode Newton divided difference ya, menggunakan metode Newton divided difference. Ada juga yang menggunakan Lagrangian. Tidak ada masalah ya. Semuanya boleh ya, karena ini memang bebas. Nah, tetapi yang terpenting adalah checking hasil. Nah, ini saya perhatikan ya, langkah-langkahnya mungkin sudah betul, tapi mungkin ya ini ya termasuk juga kehati-hatian dan ketelitian dalam memasukkan nilai di kalkulator maupun menulis ya, mungkin menulis angkanya ada yang salah sehingga langkah berikutnya salah. Nah, ini harus diperhatikan. Kalau kita punya 55.000, maka setidaknya kita lihat ya nilai ini ada di antaranya. Nah, saya lihat banyak yang nilainya tidak di antara ini. Nah, ini mestinya dijadikan apa? Checking ya. Jadi ketika kita sudah punya nilai, maka checking apakah betul enggak hasil yang kita dapatkan ini di antara 9,74 dan 9,68. Ya, jadi kita cek aja. Saya melihat banyak yang hasilnya ya 9,5 begitu ya. Jadi itu memang secara logis sudah tidak mungkin ya, walaupun metodenya, caranya mungkin betul ya, tapi saya belum lihat secara detail ya. Apakah mungkin ada perhitungan yang salah input ya di dalam kalkulator dan sebagainya. Nah, tapi dapatnya 9,5 begitu. Nah, ini harusnya dijadikan checking ya, bahwa kalau 9,5 ini kan berarti ada di bawah ini ya, berarti ada di atas 120.000. Nah, ini. Ya. Nah, kemudian yang ketiga ya. Yang ketiga di sini adalah menghitung average flow ya. Jadi menghitung debit ya, debit rata-rata di dalam channel. Yang mana ini bisa dihitung dengan Q integral dari U H dikalikan dengan DY. Diintegrasi dari batas 0 sampai B. Jadi mungkin di sini bisa saya gambarkan sedikit ya bagaimana representasi dari persamaan ini ya. Ini di dalam channel. Ya, jadi ada channel, lebar channel itu adalah dari 0 sampai B. Ya, jadi ini kalau mungkin saya coba tuliskan di sini. Ya, kalau ini saya misalkan punya channel, ini ya. Nah, ini ada kecepatannya. Ya, ini ada kecepatannya. Maka ini adalah U. H itu adalah kedalamannya ya, katakanlah H itu sekian. Nah, kemudian ada ya U itu adalah kecepatan, H itu adalah kedalaman, DY itu adalah jaraknya kemari. Jadi kalau kita buat sumbu di sini, ya, ini adalah Y, ya, katakanlah ini adalah Z, katakanlah ini misalkan. Nah, jadi DY itu adalah elemen yang ada di sini. Ini katakanlah elemen DY. Sehingga U dikalikan H diintegralkan terhadap DY itu adalah Q, debit, flow rate ya, jadi flow rate ini. Maka bagaimana kita melakukan ini? Maka ini harus dikalikan dulu ya. Jadi kita punya data U kalikan H, nah ini dikalikan dulu ya. Jadikan U kalikan H, ini dikalikan dulu, kita dapatkan hasilnya untuk masing-masing, baru diintegralkan terhadap Y. Ya, baru diintegralkan terhadap Y. Nah, ini yang harus diperhatikan adalah ya, bahwa nilai dari Y itu tidak sama. Nah, ini yang hati-hati. Saya lihat mungkin kemarin waktunya nggak nututi atau bagaimana ya. Jadi langsung aja dipakai multiple misalkan ya, multiple trapezoidal atau multiple sepertiga rule dan sebagainya. Nah, ini diperhatikan bahwa ini jaraknya berbeda. Jadi ini 0, 2, ini saya letakkan di atas ya, 4. Nah, kemudian dari 4, 5, 6 ini jaraknya 1. Ya, 5, 6. Kemudian di sini jaraknya jauh lagi, ini adalah 9. Nah, ini yang harus hati-hati. Artinya, maaf, ini 0 seharusnya di sini ya sumbunya. Nah, saya buat di sini. Ini adalah Y. Ya. Nah, misalkan ini nanti UH. Ya, perkalian UH. Nah, ini yang harus diperhatikan bahwa ini jaraknya delta atau jarak hanya step-stepnya ya. Stepnya ini 2, kalau ini juga 2. Nah, yang di sini 1 ya. Nah, artinya di sini tidak boleh kita gunakan sama semua dengan multiple. Jadi satu persamaan. Ya. Artinya di sini harus kita bagi 2 ya. Jadi nanti katakanlah ini ada satu persamaan. Ya, katakanlah grafiknya semacam ini katakanlah. Nah, maka ini digabungkan jadi 1 ya. Jadi ini maaf ini agak sulit gambarnya. Nah, ini menjadi 1. Ya, jadi kita punya 3 titik di sini. Kemudian di sini kita juga punya 3 titik. Ya, di sini ada 3 titik. Ini saya buat arsir yang berbeda. Ini satu area sendiri ya. Jadi ini diselesaikan masing-masing. Jadi ini maaf. Ini I1. Yang di sini nanti I2. Kemudian yang di sini nanti diselesaikan sendiri. Ya, ini nanti diselesaikan sendiri. Jadi nanti ini I3. Sehingga bagaimana I-nya? Berarti harus dijumlahkan dari I1 ditambah I2 ditambah dengan I3. Nah, jadi ini yang diperhatikan ya. Nah ini kalau saya lihat banyak sekali yang salah ya. Hampir semuanya langsung menggunakan multiple trapezoidal atau multiple segitiga Simpson ya, seperti itu. Jadi ini harus dibagi karena memang luasannya, jaraknya H ini tidak sama. Nah, jadi mungkin itu. Yeah, so we are discussing about the results for the evaluation the midterm exam. Yeah, and I haven't checked one by one, but I skimming all the results and I've seen that there is still some mistakes in the solution. Yeah, and we have discussed here, yeah, before that for the first question, yeah, here the common mistake is including the equation for Q1 in the matrix. Yeah. So when we want to write the form of A multiplied by a vector Q that will be equals to B, so the important thing here is that Q is for the unknown, to solve the unknown. So when we want to write down the equation for this, so we have to write for the unknown only. So that means Q will be composed of Q2, Q3, Q4, and Q5. So this is the unknown. While before we have some students solving it with Q1 included in the system, yeah, such as this one. So if we include this one, so this will be more difficult to solve, yeah, and I found out that some of you has incorrect result when including Q in the calculations. So make sure that it's only including the unknown value. Yeah. So that is for number one, and you can choose any method that we prefer. Yeah. So you can choose the Gaussian eliminations, the Gauss-Jordan, or the iterative method, yeah, such as Gauss-Seidel or Jacobian. And please note that this is required to be numerical method, means that you cannot do the regular substitution, yeah, so you cannot do regular substitution. For example, you just replace Q3, for example, with the value of Q1 in the subsequent equations, yeah. So what we want to do is using numerical method. So that is for number one. And then for number two, yeah, I think most of you has a correct method already. You can choose either the Lagrangian interpolation method, or you can use the numerical Newton divided difference. But yeah, please be careful when doing the calculations, because what we require is the value of y, which is 55,000. Yeah, so 55,000 is in between 30,000 and 60,000. So that means the value should be in between of 1.748 and 9.687. So if you find a value which is lower than these two values, so you should be careful. Yes, so you should redone the calculations to make sure that you have the correct solution. And because we have 5 points here, it means that we can attain to up to fourth order accuracy, yeah, for the equations. Okay, so that is for number two. And number three is about finding the flow rate in the channel. And we have these equations, yeah, so that means we have to do the integration for U multiplied by H. So that means we have to multiply this value first. So here we have 0.15, yeah, and so on. So that we have this value, so we insert this value into the equation to replace U times H. And then we do the integration to D from 0 up to 9. And the common mistakes is that many of you just using the regular multiple Simpsons, yeah, just using the regular Simpsons method or regular multiple trapezoidal rule, in which those methods can be used only if we have the same step size. So if we see here that now we have different step size for the range here. So here we have a step size of 2. Yeah, we have a step size of 2. While here from 4 to 6, we have a step size of 1. And from 6 to 9, we have a step size of 3. So that means the step size is not uniform, so that you have to divide the integration area. So it means you have to solve this area. Yeah, you have to solve this area, and then the second area, and then the third area. So this is the illustration of the area that we have to calculate. And because this has 3 points, it means that we can use the quadratic equation. So that means we can use the multiple one-third Simpson equations to calculate the integration of area 1 and 2. And then for area 3, we can use the trapezoidal. Okay, so that to count for the total flow rate in the channel, so that means we can just do the summation for the 3 area, the 3 integration. Okay, so that is for the midterm exam. And yeah, because I see that yeah, some of you still make some mistakes, and yeah, I think we need to have you can resubmit. Yeah, you can redone you can rework on this midterm exam and then submit it again to me. Yeah, through the classroom. You can submit it through the classroom for the 3 questions here, and that will count for the additional marking for the midterms exam. Yeah, and this you can submit this if you think that your midterm exam result is not very satisfying. Yeah. So if you think that you have done the midterm exam good already, you don't need to submit the solution again. Yeah. Okay, so I will open the assignment option in classroom later. Yeah. So if you want to have additional mark for the midterm exam, please resubmit. Yeah, with the correct solution, and that will be due tomorrow morning. Okay, any questions?
Yang pertama itu Bu agak masih bingung Bu.
Ya.
Yang pertama.
Ya. Jadi yang pertama, ya ini harus dituliskan dalam bentuk A Q sama dengan B, ya. Yang mana Q ini hanya mengandung yang tidak diketahui saja, ya. Jadi hanya yang tidak diketahui. Kalau Q1 itu tidak perlu masuk, ya, tidak perlu masuk lagi di dalam matriks dalam vektor Q. Ya. So we need only to include the unknown. So Q1 is already known. So that means we don't need to find it again here. Yeah, we don't need to repeat the calculation, the equation for Q1, but we need to find only Q2 up to Q5. So we need to solve 4 unknowns with 4 equations that we have here. Yeah. Jadi harus ditulis dalam bentuk matriks A dikalikan dengan Q sama dengan Q. Ya. B-nya apa? B-nya adalah sisi kanannya. Jadi contohnya bagaimana? Ya, untuk persamaan pertama. Ya, untuk persamaan pertama, so for the first equations we have Q1 which is equal to 3. So that means here with this equation we have Q2 plus Q3, so that will be equals to Q1, and Q1 is known as 3. So you can reconstruct this equation, yeah, in the form of A times Q equals to P. So that means that has a coefficient of 1. So that you can insert that, yeah, in the coefficient here. So A11, A12, A13, A14. This will be multiplied by Q2, Q3, Q4, and Q5, and that will be equals to the right-hand side. So if we have this equation, so that means we have Q2 and Q3, and the coefficient is 1, so that we can insert here. So A11 times Q2, yeah, so that will be Q2 times 1, yeah, plus Q3 times 1, Q4, there is no Q4, so that will be 0. Q5 as well will be 0, and the right-hand side will be equal to 3. So this is for the first equation. So you can continue for the second and the third and the fourth equations. So once you have this matrix, you have the coefficient matrix here. You have the system in the form of a matrix, so that we can solve it using any method that we use. Of course, if you want to use the Gauss-Seidel equation, so that means we don't need to solve this in the form of matrix. But if you choose to, for example, using the Gauss-Seidel equations or iteration method, it means that you can reform the equations here, so that we have Q2 that will be equals to Q3 minus Q1. If we choose to solve it using Gauss-Seidel. And then here we can solve for Q3, so that will be equals to Q4 plus Q5 and so on. Yeah? So that we don't need to solve this using a coefficient matrix here. Jadi begitu ya, mungkin sudah cukup jelas.
Sudah Ibu, makasih Ibu.
Okay, is there any question? Any other question?
Bu, mau tanya.
Ya.
Kalau misal mau mengulangi tapi yang cuma satu nomor gitu, apa dibolehin? Apa harus semuanya ditulis juga?
Oke, ya enggak apa-apa. Jadi apabila merasa yang lain betul, ya hanya satu saja misalkan, silakan dikirimkan ya. Tetapi bukan berarti nanti hasilnya jadi 100 ya. Jadi bukan berarti hasilnya itu menjadi 100, tidak. Tapi itu akan dipertimbangkan untuk perbaikan nilai ya. Akan dipertimbangkan untuk perbaikan nilai. Ya. Akan lebih baik kalau misalkan ya enggak apa-apa. Kalau misalkan salah satu merasa ada yang kurang, yang lain merasa sudah betul, tidak apa-apa, bisa disubmit saja nomornya yang mana. Okay, so is there any questions? So you have the opportunity to have additional marking for the midterm exam by resubmitting your work, yeah, which is the correct work, through the classroom, and that will be due tomorrow.
Bu, permisi Bu, mau tanya. Maaf Bu, untuk yang nomor 3 itu kan dijadikan 3 segmen untuk pengintegralnya Bu. Nah itu ketiga-tiganya tuh harus dikerjakan dengan metode yang sama tetap ya Bu? Apa boleh satu trapezoidal, satu pakai Simpson?
Boleh, gitu? Ya boleh aja.
Oh,
boleh.
Tapi nanti tetap dijumlahkan walaupun beda metode, nggak apa-apa gitu Bu?
Iya. Nggak apa-apa.
Terima kasih.
Ya. Yang penting kita upayakan supaya mendapatkan keakuratan yang terbaik ya. Jadi diupayakan untuk mendapatkan keakuratan. Kalau misalkan ya, tidak apa-apa sebetulnya. Misalkan ini ya, so in this case in number 3, yeah, you can use any method that you want to use, so that it will be no problem. Yeah, for example, here we have a range, an area from 0 to 4, in which this has a homogeneous step size, homogeneous step size of 2. So if we have this, if we want to solve the first area here, for example, with not using the 1/3 Simpson rule, but you choose the multiple trapezoidal rule, so that will be okay as well. Yeah. So you can choose any method that's suitable for this, in which you think that will give an accurate result. But please be careful. So the main thing is that this problem has different step size. So that is the main concern. So you cannot use one method, for example, one multiple method to solve all the area here as one region, as one area, because the step size is not uniform. So that you have to divide it into several areas. But for solving any area, for solving any one of the area here, you can use any method that you prefer. Jadi bisa apa saja ya, metodenya juga tidak harus sama. Misalkan ada trapezoidal untuk yang pertama, yang kedua menggunakan metode Simpson, yang ketiga menggunakan Simpson, atau ini boleh dicampur-campur ya. Tapi yang penting intinya adalah pada step size yang tidak sama ini. Jadi bagaimana kita menyelesaikan step size yang tidak sama. Karena kalau kemarin yang saya lihat itu langsung dikerjakan multiple begitu ya, menggunakan multiple Simpson tapi dari 0 sampai 9. Jadi langsung limitnya dari 9 dikurangi 0 dibagi dengan jumlahnya berapa. Misalkan di sini 1, 2, 3, 4, 5. Berarti di situ kita mengasumsikan bahwa jaraknya itu sama begitu ya. Jadi jaraknya itu step size-nya sama, padahal di sini tidak sama. Jadi tidak bisa langsung menghitung sebagai satu area, tetapi harus dipecah menjadi 3 area di sini. Itu pada prinsipnya. Ya mungkin gitu ya.
Iya Bu, terima kasih Bu.
Ibu, saya ada pertanyaan lagi Bu ya. Yang soal nomor 3 ini kan pengaruhnya B itu di mana sih Bu sebenarnya Bu? Itu kan ada B total, kita yang mengintegralkan dari 0 sampai B. Nah, saya sudah mengalihkan ini, cuma kemarin itu B-nya tidak ada, karena kan tidak ada nilainya di situ, jadi kita nggak ikutkan gitu Bu.
Apanya itu yang tidak ada nilainya?
B.
Kenapa? Gimana? Bisa diulangi pertanyaannya tadi, diintegralkan, tetapi
pengaruh B-nya itu Bu, itu kan kita kan mengintegralkan dari 0 sampai B ini. Nah, jadi UH dikalikan D-nya. Saya memang mau melakukan ini juga Bu, cuman kemarin ini ada nggak pengaruh B-nya gitu loh Bu. Jadi di mana sih sebenarnya pengaruh B itu Bu?
Iya, jadi B itu kan lebarnya ya, total width-nya. Jadi total channel width itu lebarnya. Berarti kalau ini tadi diambil DY, berarti B itu adalah dari sini sampai sini, ini sampai ujung di sini, ini adalah B titik ini.
Oh iya Bu.
0 sampai B, mengintegralnya dari 0 sampai B. Nah artinya kalau dengan cara seperti ini, berarti B-nya nanti angka 9 ini, itu adalah B-nya. Nah tetapi pengerjaannya tidak langsung dari 0 sampai 9, tetapi harus dipecah ya. Jadi seolah-olah kita menyelesaikannya dari 0 sampai 4 ya. Seperti itu. Ditambah lagi ya UH, UY, HY, DY. Ya, ditambah dengan pengintegralan dari 4 sampai 6 begitu. Jadi kita pecah-pecah. Seperti itu. Kemudian ditambah lagi pengintegralan yang ketiga yaitu dari 6 sampai
9. Baik Ibu.
Ya. Okay. Is there any other questions?
Yeah.
Yeah.
Sorry. For the matrix solution, for the solution of the matrix, if we want to solve the problem, we should show all the steps, or it's okay if we shortcut some steps, because it's so long and the time is really tight and limited, and when we during the time of the exam.
Yeah, so here what we do in numerical method is learning the steps. So the step is crucial as well. So that will be included in the marking as well. Yeah, because if we don't show the step, so this we will not. It will be difficult to trace the understanding of the method. Yeah, so it's crucial as well to include the steps in the calculations. Yeah. Because if we want to get the final result, we don't need to learn numerical method. You can use any software available there. You can use Excel, you can use Metnum or other software in which you can just insert the value and that pop, you have the you have to answer. Yeah, but here what we want to do is to learn what happens behind it. So the steps are crucial as well. Yeah, so that will be included in the marking. So please, yeah, if you have this sort of problems, yeah, so please make sure that you write down the steps, yeah, step by step, clearly. Yeah, is that answering your question, Ahmed?
Yeah, no, thank you.
All right, yeah. So you have the opportunity to rework on this, yeah, and submit it by tomorrow morning, yeah, tomorrow morning before 7 a.m. in the morning. Okay. All right. So if there is no questions, we will continue on the topic today that we are going to discuss. Yes.
Ibu, I have one question.
Yes, Jonas.
Yeah, for question number 2.
Yes.
So when we use integration, just for the first one from base 4, and for the second one 6 to 4. Yeah.
Yeah. So for number 2, you are asking about number 2.
Yeah. So we have to add together all of them.
No, yeah. So number 2, if we look at the questions here, we have this data, yeah, in which this is the gravitational acceleration as a function of altitude, yeah, or height, as a function of altitude or height. So we see here that if we have increasing altitude, yeah, increasing level, so that means the gravitational acceleration will be decreasing. So the question is, we want to find the gravitational acceleration at y at the altitude of 55,000 meters. So that will be around the value in between the value of 30,000 and 60,000. So logically thinking that if we want to find the value here, so that means the value should in between 9.7487 and 9.6879. So it should be in between this value. Yeah. If you want to be very simple, you can use linear interpolation. So you just do the averaging between the two, so that you can find the slope between that, and then you can find the value at 55,000. But here the question is to find the value, the interpolation to the highest accuracy. So if we look again of what we've learned using the Newton's divided difference or using the Lagrange interpolation methods, so that with 5 points that we have, yeah, if we have 5 points, so that we can get an interpolation up to the fourth order equations. Yeah, fourth order equations. So this will be the highest accuracy that we can get using 5 points that we have from the data. So that using the Newton's divided difference or Lagrange interpolation method at fourth order, you can get the result at 50,000. And that value should be in between the two values here. Yeah, so this is not the integration, but this is the interpolation case. Yeah.
Oh, okay.
Yeah. All right. So yeah, I think that for the discussion for the midterm exam, yeah. Now we will continue on what we are going to learn today, which is about the ordinary differential equations.
Oke, Bu. Terima kasih.
Yeah, sama-sama. Okay, so we will look at here. Yeah, so this is the ordinary differential equations. What have you known before about ordinary differential equations? Have no idea?
Mau tanya Bu, yang nomor 2 tadi Bu.
Okay, so we will look here what is the differential equations. So if in part in the previous part, we have learned about the set of linear algebra equations, in which for that we have learned the matrix as well, how to solve it using Gaussian elimination. So that is for the linear algebra equation. Yeah. And which for the linear algebra equations, we learned that all of the parameter is in the linear form. Yeah. Well, if we have the differential equations, it means that the variable will be in the differential form. Yeah, it means that we have a differential form. So what is the example here? So that here we have in terms of dv over dt. Here, so dv over dt here is differential variable, because we have d over dt. So this is differential in terms of time. So here it means that we have a differential equation because we have this form in the equation. Now here we have in the example is the parachutist that we have learned before, in which p is the dependent variable. So p is dependent. So you see here that p, the variable p appears 2 times in the equation. So one in the form of linear, in the order of 1, and the second in the form of differential. So p here acts as a dependent variable, while the independent is t. So whenever t value is changed, so that means the velocity here will be changing. So t depends on the value of t. So t is the independent variable, and p is the dependent variable, depends on t. And this is called the ordinary differential equations. There are other forms of differential equations, which is called the partial differential equations. So differential equations has 2 forms, ODE and PDE. So ODE means that the variable depends on one independent variable. For example, what we had before P, it is a function of time. So it means that P only depends on time. But partial differential equation is when we have the variable depends on 2 other variables. So it depends on 2 or more, or more independent variables. So what is the example? Yeah, the example. Say we have velocity as a function of x and y. So it means that p depends on the value of x and also y. Whenever we have a translation to x direction or y direction, it means that the value of t will be changing as well. So this is called PDE. So what we are going to learn in this week is ODE. This week, it's ODE. While PDE we will learn as well after we finish ODE. So we will learn both of these equations. So this is the example. So if we talk about derivatives, we have in mathematics, in the mathematics notations, we have T notation for the derivative, and also we have del notation in the derivative. So this is slightly different. When we do the calculation, it looks similar between del d and del, but actually it has different meanings. So if, for example, we have dp over dt, so that means p is only a function of t. So that when we get this derivative, so that will be the total derivative of the velocity. While if we have the form of del, so this means that is a partial derivative. So del u over del y, it means that del y, it means that u, this is the derivative of u in respect to y. But u is not only depends on y, but it also depends on other variables, for example, t or x. So that means here we have this one, so dv over dt will be the total derivative. While here we have u, which is a function, for example, of x and y for partial derivatives, for example. So that means we have del u over del y, and also we have del u over del x. Yeah. So this is the difference between using g and del. Yeah. So it looks similar. The calculation is uh, similar, yeah, but the meaning is slightly different. So that if we input that variable in the form of differential equations. So here, for example, we have t squared t over t2 squared. So this is the second derivative, yeah, second derivative of t in respect to time plus 6tv, that will be equal to 1. So this is the example of ordinary differential equation. Or also we can have the partial differential equation, which is the second derivative of u in y directions minus the second derivative of u in x directions, that will be equal to 0. Yeah. So that we see here, yeah, is there are two types of differential equation. Now we will talk about this one first. Yeah. So this is the example. Yeah. This is first derivatives. Yeah. Function ODE with one first derivatives. Yeah. And the second one here, in which we have a function ODE, which is has the second derivative. Yeah. So here we have the second derivative as well as the first derivative. And here the unknown is x, unknown function is x, and the independent variable is t. And so x is dependent and t is independent variable. And there are some type of ODE. We can have a classification of first order, second order, or nonlinear, or linear and nonlinear. So this is the example. Yeah. So if we have so if we have here the linear first order, so that means we have here is first order, and this is a linear equation. And also we can have the first order equation in which this is nonlinear. So it can be a function, for example, here as y squared minus x squared and so on. Yeah. So this will be non-linear, while this one is linear. And also we can have the second order equations. When we have a second order equations, means that we have an equations that consists of the second derivative. Yeah. So the order of the ODE that relates to the derivatives, the highest order of the derivatives in the equations. Yeah. So here we have the second derivatives as well as the first derivative, because we have the second derivative. So this is called the second order equation of ODE. Okay. And if we have a higher order equations, now later we can apply the discretization scheme to reduce the system of higher order to the first order equation. So we will learn about that. Yeah. And this is the another example of linear second order equations here. Yeah. So we have a linear form here. Well, this one can be a form of a quadratic or the cubical and so on. Yeah. So this is a linear form of second order ODE. Second order because it has second derivatives in the equation. Okay, so we will look at back again to the example of the parachutist, in which we have this case since the first week of our class, of our course. Yeah? So that when we have the Newton's law here, we can apply the Newton's law for the parachutist case, in which we have the equation shown here. And here we have the analytical and the numerical solutions. I think we have learned this before. Yeah. So we can do the actual integration form using mathematics. So we end up with these equations, or we can use a discretization scheme, yeah, so that we approaching the value of T here with delta T over delta T, or we can write it down there as delta T, so that will be the delta T, so that will be Pi plus 1 minus Pi, so the value of the velocity and subsequent time step minus the value of the velocity at the current time step, yeah, over the step size. Yeah, so that we can write this as T minus T over M multiplied by T. Yeah, multiplied by T. So that we can move that delta T to the right hand side. Yeah, and then we move that as well Pi here to the right side, so that we have this equation. So this is the solution, yeah, and this is what we solved before here. So that is the ODE. Yeah, so ODE, what we solved before is the ODE, and this is the solution that we have. Okay, so we will look at the first method that we discussed to solve the ODE. So this is the scheme to discretize to make the derivative form becomes the linear equations, yeah, because we have the derivative form, yeah, so the goal is to transform the derivatives into the linear form, linear algebra equation. Yeah, so change the derivative. So here we applying the discretization scheme. So the first one is using the Euler's method. So what is performing the Euler's method here? So if we have an equation of dy over dx, yeah, or the dy over dx here is a slope, yeah. So if we have a curve here or a function of x and y, yeah, so a function of x and y here, so dy over dx here is the slope. So this is the slope. So that we can, using the same step as before, yeah. So using the same step as before, so dy over dx, yeah. So that will be delta y over delta x, in which that will be yi plus 1 minus yi over delta x. And delta x here is xi plus 1 minus xi. Yeah. So that here we can rearrange the equations. So that will be equals to fxy. Now if xi plus 1 minus xi is the step size h, so that we have yi plus 1 minus yi, so that will be equals to fxy times that goes up there, so that times h. So that we move that to the right side, and here we have the equations. So this is called the Euler's method, yeah, in which if we have, yeah, if we have the value of, we stand up here, for example, we are at this position at xi, and we know the slope here, we have the value at xi, and we have the slope there, so that we can use the slope to project the value at xi plus 1, yeah, so that we can project the value there using the slope, yeah, so we project the value there. And then from here, we can also project to another point there, for example, to xi plus 2, for example. So this is called as well, sometimes it's also called as projection method. So we project the next value based on the previous value and the slope, yeah. So we see here that if we want to get the value of the subsequent value, we can find it from the current value plus the slope times the step size, the distance in which it will be projected. So this is how the Euler's method works. And if you look at the error that is introduced by the method, so you can see clearly that in Euler's method, because it's projected using the slope here, so that this is the predicted value, while the true curve here, for example, is here, so that we have a true value is here. So this is the error, the difference between the predicted value and the true value. So that we will look at the example now. Yeah. So say, for example, we have ODE, and the ODE is this equation. So we have dy over dx, or the slope will be equal to minus 2x to the power of 3 plus 12 squared x minus 20x plus 8.5. And here, what information that we need for ODE is that what solution that we want to find. So we want to find the solution from x0 up to x equals to 4. So if we have this x and y plane, yeah, so we want to find x0 up to 4 with a step size of 0.5. It means that we want to find the value. We have the value of the initial condition is the value at x equals 0, and that value y equals to 1. So this is the first point that we have. And that we will use this initial point to predict the value in the subsequent time step. So that means the subsequent time step will be at 0.5 because we have the step size of 0.5. And then next it will be projected, this value will be projected to another value which is at 1. And then this will be projected again, we find the slope, and then this will project to 1.5 and up to 4. Yeah, up to x equals to 4. Yeah, so that we walk from the first point, and then we get the subsequent point using the slope for each of the points. So this is how it works. Yeah, so this is how we do the calculations. So this is the basic equations that we have for the Euler's method. And we're starting from 0. Now we want to find the value at 0.5. So how to find this value is that we use this equation. So y at 0.5, that will be equal to yi, the point before, which is 0, plus the slope at this point. So we have to find the slope at this point, which is fxi yi. Why we need fxi yi? So this will be fxi yi. Why? Because this is the slope. So this is dy over dx. So this is the slope. Yeah. So that if we want to find the slope, which is dy over dx, so this will be a function of xy here on the right hand side. So that if we want to find the slope at this point, so we insert the value of 0. Yeah, we insert the value of x equal to 0 and y equals 1. So we insert this equation there. In this case, we don't have y value here, so that we need only the x value. So we insert the value of x here. So that will be 8.5. So we see here that the slope will be 8.5. And delta H is 0.5. So we step on 1 here, so that will be 0.5. So we multiply with 0.5 plus y0 is the initial value is 1. So that we have the value of 5.25. So that means this point is at 5.25. And then we have this point, and then again we need to find the slope at this point, and then we can project it to find the value at x equals to 1 to get the value of y there. So we proceed to the next step to find y at x equals to 1. That will be equals to y at 0.5 plus the slope at 0.5, and the x value is, the y value is 5.25, yeah, here. And that will be multiplied by the step size. So we need to find the slope here. So to find the slope, we insert it here. So this is the slope. We insert the value of x equals 0.5 and y equals 5.25. Because this is only a function of x, yeah, a linear form. So that means we don't need to insert that one. We need to insert only the value of x here in the equation. So that we will have the slope And this is the calculation. We insert the value of 0.5. So this will be the slope at that point, yeah, and multiply by delta H with H, which is the step size, so that we will have the result of 5.875. So that means we have the value here is 5, yeah, 5.875 for the next. And then for Y, this should be 1.5, yeah, so this is a typo. We go on to the next time step, which is the next step, which is at x 1.5. So this should be 1.5. This should be corrected. Yeah, 1.5. And this can be calculated from y equals at x equals to 1, yeah, plus the slope using the value at here. So we need to find the slope again here, inserting x value and y value in this equation, and multiply by h, so that we have the result of 5.125. So this is the projected result here. So this will be at 1.525, and so on. So we can continue on the calculation up to x equals to 4. So we repeat this procedure, yeah, we repeat the instruction so that we have the full solution up to x equals to 4. So this is the result. Yeah. So using H 0.5 here, so that we have these results. So this is the result at 0.5. This is the result at 1. So we do some the projection here. This is 1.5. So that we have this point, yeah, which is calculated using the Euler's method. Yeah. So that a total of 8 points, yeah. So this is initial, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Total of 8 points. So, okay, any questions? Ya, silakan Pungki.
Mohon maaf Bu, izin bertanya. Yang tadi itu apakah selalu Y-nya itu dimulai dari step size-nya Bu? Kalau lebih dari step size apa tidak diperbolehkan ya Bu?
Y-nya lebih dari, maksudnya Y-nya lebih dari step size ini?
Y 0,5 ini loh Bu. Ini kan menghitungnya dari step size-nya ini Bu.
Oh iya.
Kalau
iya.
Harus itu Bu, harus dari step size ya Bu berarti?
Iya betul, harus dari step size ya. Ya, jadi harus dari step size. Jadi step size itu tujuannya sebagai guidance ya. Tujuannya sebagai guidance untuk menentukan titik berikutnya itu di pada X berapa begitu. Jadi memang kalau memang inginnya langsung misalkan ini bisa saja kita menggunakan step size yang lain ya. Tapi dalam kasus ini memang kebetulan diminta 0,5. Ya, jadi kita gunakan step size 0,5. Artinya perhitungan berikutnya mengikuti step size-nya. Jadi XI plus 1 selalu XI ditambah dengan H. Ini step size. Yeah. So that we always calculate the next point with this calculation. Yeah. So that depends on the step size. Ya, jadi cara pengerjaannya cukup sederhana ya. Jadi sebetulnya intinya adalah bagaimana kita memanfaatkan slope yang kita punya, informasi slope yang kita punya di sini untuk memproyeksi ke depan, begitu ya. Proyeksi ke depan lagi dan seterusnya. Jadi yang harus dipunya, ya harus informasi yang harus ada apa? Harus ada initial value. Tidak mungkin kita tidak punya initial value karena nanti tidak bisa berlanjut perhitungannya. Jadi syaratnya di sini, yeah, so there is a requirement for this ODE to be solved is that it should always have the initial condition, and that's why it's called the initial value problem. So this ODE is called as initial value problem because it needs the initial value to go on to the next calculations. So this is the required one.
Baik Bu, mohon maaf lagi Bu. Kalau untuk yang solution between X sama dengan 0 itu kalau kita hitung apa tidak masalah ya Bu? Kalau kita menghitung dari mulai 0 gitu.
Solution between
X sama dengan ya ini.
Ya. Ya, kalau ini kan X sama dengan 0, 0-nya solusi diantaranya ya. Jadi 0-nya tidak perlu dihitung karena diketahui di sini.
Ya. Terima kasih, Bu.
Ada pertanyaan lagi mungkin?
Ada, Bu. Saya ya, Bu.
Ya.
Masih mau tanya. Kalau kalau saya nggak salah, Bu, saya itu kan persamaannya sama seperti Newton polinomial itu, Bu, yang untuk first order. Nah, mungkin ada perbedaan, Bu, mungkin di sini antara Euler's method ini dengan.
Iya, jadi sebetulnya memang fisiknya sama ya. Pendekatannya ini kan secara linear memang. Jadi kalau Newton polinomial kan juga first order ya. Jadi memang di sini pendekatannya ya, betul. Ini adalah pendekatan first order. Nanti kita akan lihat berikutnya ya. Jadi memang betul pada prinsipnya metode numerik selalu gitu, mau didekati dengan first order, second order, third order, nah itu ada ya, seperti itu. Jadi memang Euler method ini adalah metode paling sederhana, basisnya adalah linear, jadi first order, betul. Ya. Sama juga yang dilakukan di Newton divided first order yang sama memang. Ya, karena basisnya kalau itu hanya untuk interpolasi, tapi basisnya adalah dengan ini sama. Ya, pada prinsipnya sama.
Ya, baik, Bu. Terima kasih, Bu.
Yeah, so this is so you are correct. Yeah. So this is the simplest method using very simple. Here you can see this is a linear. So we assume that the point, the line, the curve that connecting the 2 points here is a linear line. Yeah, so this is the simplest form. So you can see this is in first order. The most simple form for solving ODE. Yeah, you are correct. Right. So that we will continue on here so that you can see if, for example, here is we have the true solution which is indicated by the solid black line here. And this is the value, the black points here are the value that we obtain from the numerical method using Euler's method. So we can see that this is the error. And this is quite large. And we want to think of how to minimize the error. So there is one way to minimize the error in which we also learned this before, yeah, that we can apply this using smaller time step. Yeah. Because if we are using the smaller time step, it means that, yeah, for example, there is a difference, yeah. So that we can see here that if we have a difference here, the error, so the error is reduced greatly when we make it half, yeah. And this will affect to the calculation later, yeah. So we see here that if we, for example, divide here, h, which is half of the initial h, yeah. For example, we divide it into 2, so this becomes half. So you can see here that the error is also reduced. Yeah. But on the other hand, you can see that the number of calculation will be twice. Yeah? So that for h 0.5, you have large error, but you need only 8 points to get the result at x equals to 4. But now with the time step of 0.25 here, you will need 16 calculation. Yeah, so you have more points here. It means that you calculated every 0.25 here. So that you will have 16 calculation. 16 calculation. Yeah. So that you can see, yeah. We have to find the optimum later, yeah. Whether we want to increase the accuracy to reducing the error, yeah, with a small the time step as small as possible, but on the other hand, it will, yeah, it will increasing the calculation. Okay, so this is how to write in MATLAB, yeah. And this is in the coding. Yeah, if we want to make our own coding for the Euler's method. So if we have these equations, for example, dv over dt, that will be equal to 1 minus 2 p squared minus t. That, and we have the initial condition. We have the initial value that p at 0, p at 0, that will be equal to 1. Yeah, so this is the initial value. Yeah, so this is initial value. And this is the function, the ODE. And you can see that this is a slope. This is the equation of the slope. And this equation is a function of t and t. Well, if we see on the previous calculation here, yeah, we see that this is the slope. And this equation is only a function of x. Yeah. So it's not a function of y. So even though we insert the value of y here, it doesn't have effect on slope, the calculation of slope. So here we have slope only as a function of x. While here the difference for the second example here, we have a slope which is a function of t as well as the dependent variable t. So both value when changing, it will change the slope. Yeah. So this should be careful. Yeah. So it means that we need to insert the two values there. And for example, we want to find with the time step size of 0.01, so this is h value, and we want to repeat the calculation up to 100 times, so that means that we will calculate it at to 1 second. Yeah. So 100 times 0.01, so that will be at time second, 1 second. So we will calculate from t0, which is the initial value here. So t is already known as 1. And then we calculate to another time step, which is 0.01, and then 0.02, and so on up to 100. So this will be t1, t2, and so on. So this is how to write it in MATLAB. Yeah, so we define first the equation. So we can just input the equation in the form of f. So this is a function which is inline. So this is anything after the bracket of the inline function here is the equations that we want to solve. So that will be 1 minus 2 times p squared minus t. So this is the equation. 1 minus 2 p squared minus t. So this is the equation in the first single quotation mark here, and then you have another single quotation mark which is t and p. So this is the variable in the equation here. So that is the variable there. And then we give an initial value here. Yeah. Also, this is the time step. This is a step size, and this is the initial value. Yeah, and we insert this. So this is inserting the initial value in the calculation here. Yeah. Okay. So this is then we do the calculation here. So this is the Euler's method. And then we do looping up to 100 times, so that we have t will be equals to 1 second. Yeah. Okay. So that is about writing the code in MATLAB. So this is the solution. When we want to plot, so you can use the plot PP here. So this should be the same. Yeah, so this will be the array. So if you look at here, it will store it as in array. Yeah, so this is storing information in the form of array. So we have two arrays. We have the arrays for T and arrays for P. Yeah, in which we have from 1, yeah, up to 100. Yeah. Yeah. So 1 up to 101. This is the array from 1 up to 101. Yeah, so this is to store the memory. Yeah. So that once we have that, we can plot it. So we call the array here for the time and the velocity so that we have this plot. Okay, so this is the example of writing up the code using MATLAB. Now we will look at if we have the system of ordinary differential equations. So this means that we have to find the solution of this one. Yeah. Before we have a set of linear algebra equations in which we have, for example, 5 equations to solve for 5 unknown. While here we have a set of ordinary differential equations in which we have, for example, n equations to find for the n unknowns of y. Yeah. So that we can combine the equations, we can solve these equations, yeah, using the Euler's method as well. So how to solve the system of more than one equations using the Euler method? So that, for example, here we want to find the solution between x equals to 0 and 4 with the subsets of 0.5, similar to what we had before. And now the initial condition at x equal to 0, the y1 value is 4 and y2 value is 6. Now the same applies for this. If we have two equations to find y1 and y2, so that means we have to put the initial for each of the unknowns. Yeah. So for y1 and also for y2. So we have to get the initial value for all of the unknowns. So for example, we have n unknowns. It means that we have to provide n initial conditions for 1. Okay, so this is the equations that we have. So this is the first and this is the second equations. So that means the y value, y1 and y2 value should satisfy both equations, yeah, because we want to find the solution for the system. Okay, so we will apply now the Euler's method. So this is the Euler's equation. Yeah. So that we will start with the first equation. We do the same thing. Yeah. We will start from x equal to 0 to find the next point, which is at 0.5. And how to perform this? We will calculate one by one. So we will start with the first equation. So that we have yi plus 1. So that will be the value of y1 at 0.5. So we get 1 here. It means that the value of y1 at 0.5, that will be equal to y0, which is 4. Okay, yeah, y10, which is 4, plus the slope. Yeah, so the slope, we insert the value. Yeah, so we insert the value of y1 equals to 4 in the equation here. Yeah, so we insert in the equation. So 0 minus 0.5 times 4. So this is the slope. Yeah, so this is the slope. Times the step size here, h is 0.5. So that we calculate that we have y1 at 0.5 equals to 3. So that we can continue to the second equations to solve for y2 value. Yeah, so that y2 at 0.5 will be equals to 6. Y2 value at the previous time step, which is 6. Yeah, plus the slope. So this is the slope. So that will be 0.3 times 6 minus 0.1 y1. So the y1 value here is not the new value, but this is the value at the previous time step, which is 4. So please make sure here. So although we have the new value, this is what required here is the value at the previous time step. Yeah. So not using the new value, but using the value from the previous time step, which is 4, or the initial value here. So that this is the slope calculated from the point before, So that's why it should be taken at the previous time step because it is taken from the point before. So the slope from the point before times the step size. So that we do the calculation, that will be 6.9. So this is the result of y1 and y2 at x 0.5. Again, we can do the same for x equals to 1, the next time step here. And again, using the same way. So if we want to calculate here, yeah, so that we want to calculate y1 at 1, so that will be equals to y1 at 0.5 plus plus the slope. So that means the slope is the equation, so that will be minus 0.5 times y1 at the previous time step. So y1 at the previous time step is 3, or this one. So that will be 3. And that multiplied by the step size of 0.5, so that we can calculate. So this will be equal to 2.25. Y2 value here, calculated the same. So y2 at 1 will be equals to y2 at 0.5 plus the slope. So this is the slope. So that will be 4 minus 0.3 times y2 at the previous time step. So y2 at the previous time step is 6.9. 6.9 minus 0.1 at the previous time step. Y1 at the previous time step is 3. Yeah. And that multiplied by 0.5. Okay. I hope this is clear enough. Yeah. So that we can calculate this, that will be equal to 7.715. So this is the solve for the set of ODE equations, yeah, ordinary differential equations, yeah, to solve for the unknowns y. Okay, any questions? Ya, jadi caranya, ya, ini bisa kita gunakan tidak hanya untuk satu persamaan saja yang ingin diselesaikan, tapi juga bisa lebih dari satu. Jadi dalam bentuk set persamaan, ya. Kalau kemarin kita buat kalau set persamaan aljabar itu kita buat dalam bentuk matriks. Nah, kalau ini dengan Euler's method kita kerjakan satu per satu, ya, dengan memproyeksikan slope-nya masing-masing dari masing-masing persamaan itu. Ya, artinya dikerjakannya tetap terpisah, ya. Jadi untuk Y1 dikerjakan sendiri, Y2-nya dikerjakan sendiri berdasarkan initial value yang ada, tinggal dimasukkan saja. Ya. Jadi artinya memang ini tetap mengerjakannya adalah terpisah, ya, terpisah. Dalam artian tidak dikerjakan dalam bentuk matriks secara simultan, tetapi tetap berangkat dari initial value yang kemudian masing-masing diselesaikan. Tinggal nanti Y1 dan Y2-nya saja yang nanti dicari dari nilai sebelumnya. Okay. Okay, is there any question? Okay, if there is no question, so we will look at the improvement of this method. So we see here that the downfall of the Euler's method is that the derivative of at the beginning of the interval is assumed to apply across the entire interval. So if we see here that, for example, here, yeah. So we see here that the first derivative here will have significant effect to define the error of the subsequent iteration. Yeah. So for example, here I do over-predict, for example, over-predict the slope here, for example, sorry, there. Over-predict the slope there, for example. So that will increase as well. Yeah. So that you see that the calculation here, yeah, the error for the entire calculation will depend on the slope here, yeah, on the initial slope. So this is the downfall of the Euler's method. So that we will look at the other example here, the other method. Yeah, so we have some modifications. We can have the Hume's method, the midpoint method, and the Ralston method. So we look here. So what we perform here, yeah, the first one is the Hume's method, in which it will apply the predictor and the corrector. So how was the principle of this method? So we see here that the predictor here is the same to the Euler's method. So this is the standard Euler method. So the Euler's method here is used as a predictor. Yeah. So what happened here, that this value, the Euler's method is used to predict the new value here as before. But then at the new value here is not used directly as a result, but instead this value is then corrected. Yeah. So here we will find a slope again at the second point. So here at the new point, yeah, at the subsequent point, we will find the slope at that point, and then what happens? We find the average between the 2 points. So the average between the average of slope at the first point and the second point, that will be here. So this is the average. And the average slope here is the one that is used in the final calculation. So this is the final slope that we use. So still, we use the Euler's method, yeah, similar to Euler's method, in which we use the slope to predict, but the slope now is not taken from the first point. Instead, it is an average between the slope at the first and the second point. Okay, so is that clear enough? Yeah, so don't look at the equations because we have many notations there. It looks a bit confusing, but if you know the principle, yeah, it will be easy. Yeah. So how to use the Yun's method is that it will do projection to the next point based on the value of the first point and the slope. But the slope is not taken directly from the slope at the first point. Instead, the slope that is taken here is the average between the slope at the first point and the slope at the second point. So that with this average, the averaging of the slope, it means that it will closer to the final solution, to the actual, to the true solution. Okay, so this is the Yun's method. Yeah. And the second, we have the second method, which is the midpoint method. So one is performed in the midpoint method is basically looking at the trend that we have before. Yeah. So we look at the trend here, in which we find out that if, for example, we stop the slope here, the projection stop at half of the point here. So that means we can use the projection, we can reduce the error. Yeah, we can reduce the error. So if we use the slope directly to a larger time step here, we have a large error. But for example, if we stop the slope at the midpoint here, and then we calculate the slope, and then we get the point here, so we see that we have a reduced error. So this is the basic idea of the midpoint method. Yeah. So how is the midpoint method works? So what we see here, that actually we want to project it to xi plus 1. Yeah. But before that, we stop the slope. So we use the slope here to project to the midpoint first. Yeah. So we project to the midpoint first. So that means we find the value at the midpoint. So yi plus half, that will be equal to yi plus the slope times the distance. Now the distance is not h, because h will be the step size up to xi plus 1. So if this is half, so that will be
half of h. So that if we have the value of I plus half, so this value then will be inserted into the equation to find the new slope, which is projected from this point, which is used to find the slope. Yeah, so this is finding the slope at midpoint. So once we have the slope here, so that we use the slope to project it again from the initial point. Yeah. So here we don't do the projection from I plus half. We don't do the projection there, but instead we use the slope here in xi. So that this is similar, yeah. So that we use the projection from still from xi, but the slope here is calculated by the slope which is taken at the midpoint. So this is only intermediate step, yeah, to calculate the slope here, yeah. So this step is only to calculate the slope at the midpoint. Once we have the slope at the midpoint, so then we will project it again from xi to get the value at xi plus 1. Okay, any questions? Is this clear enough? Baik, coba saya ulangi dalam bahasa Indonesia ya mungkin ya. Jadi kalau memahami ini mungkin tidak usah melihat persamaannya ya. Kalau lihat persamaan ini subscriptnya banyak sekali, notasinya ada setengah, ada i ya, yang di sini ada 0 dan sebagainya, ada subscriptnya. Nah mungkin agak membingungkan, tapi pada prinsipnya adalah bagaimana cara kerjanya itu yang harus kita pahami. Jadi kita kembali lagi ke metode improvisasi yang pertama, ya, yaitu metode Hyun. Jadi apa yang dilakukan di dalam metode Hyun di sini adalah melakukan rata-rata, ya. Jadi melakukan rata-rata dari slope kemiringan. Jadi kita tahu ya bahwa ini kalau kita punya poin 1 di sini pada xi, ini kita punya slope, kemudian pada xi plus 1 kita juga punya slope di sini, ya. Artinya kalau kita ingin cari slope di sini, kita harus cari dulu nilai y-nya, karena nanti nilai y ini yang akan kita masukkan ke dalam persamaan untuk mendapatkan slope-nya atau kemiringannya, gradiennya. Jadi di sini metode Euler standar digunakan untuk memprediksi nilai y pada xi plus 1. Ketika sudah dapat nilai i, maka nilai ini dimasukkan ke dalam persamaan untuk mendapatkan slope, untuk mendapatkan kemiringan pada xi plus 1. Nah, slope yang dipakai nantinya terakhir itu adalah slope rata-rata, kemiringan rata-rata dari kemiringan pada xi dan kemiringan pada xi plus 1. Jadi dijumlahkan dibagi 2. Begitu slope-nya. Jadi yang kalau ini slope-nya tinggi, ini slope-nya rendah, nanti di antaranya. Ya, jadi kita lihat kemiringannya nanti di antaranya. Dan bagaimana proyeksinya? Tetap pada prinsipnya proyeksi itu berangkat dari titik xi. Jadi tetap berangkatnya dari xi. Sehingga tidak berangkat dari tempat yang lain, ya, jadi tetap berangkat dari yi, diproyeksi ditambah dengan slope kalikan dengan jaraknya. Jaraknya tetap h. Ya, jadi jaraknya tetap h. Nah, yang berbeda ini slope-nya yang kita gunakan ini yang mana? Begitu ya. Kalau Hyun tadi langsung dari titik pertama, slope-nya digunakan untuk memprediksi kedua. Kalau yang Hyun method ini, slope pertama hanya digunakan sebagai bantuan untuk mencari titik kedua, yang mana titik kedua ini nanti mencari slope-nya. Final slope yang digunakan adalah rata-rata dari slope 1 dan slope 2. Gitu. Otomatis nanti hasilnya akan lebih akurat. Karena ini menggabungkan dari apa? First order yang di bawah dan order yang kedua. Nanti ini berarti order akurasinya. Cara kedua yaitu dengan midpoint. Kalau midpoint itu kita bantu dengan titik tengah. Pada prinsipnya kita tahu tadi ya, kalau kemiringan itu menghasilkan error, kalau kemiringannya salah nanti errornya juga besar, maka kemiringan ini kita hentikan di tengah-tengah. Jadi kita proyeksikan untuk titik di tengah. Nah, di tengah ini kita cari slope-nya. Artinya slope yang kita ambil, kemiringan yang kita ambil bukan kemiringan pada titik pertama, tetapi kemiringan yang kita ambil adalah pada titik tengah. Nah, kemiringan pada titik tengah ini nantinya digunakan untuk memproyeksi tetap berangkatnya dari xi. Ya, tetap berangkatnya dari titik pertama. Jadi bukan berangkat dari I plus tengah, bukan. Tetapi tetap berangkatnya dari XI, dari titik awal. Tetapi slope-nya ini saja yang diambil dari midpoint. Nah, jadi kita lihat di sini tetap berangkat dari GI. Ya. Nah, nanti slope-nya yang diambil dari titik tengah-tengahnya. Jadi bukan diambil slope dari depan atau slope dari belakang seperti tadi, yang di rata-rata, tetapi langsung diambil di titik tengah. Ya, dikalikan dengan jaraknya, tetap jaraknya adalah H. Ya, karena ini hanya digunakan sebagai apa? Hanya digunakan sebagai slope-nya saja untuk mencari slope. Nanti dikalikan dengan H itu adalah jaraknya, tetap sama. Nah, itu adalah midpoint. Nah, sehingga secara umum ini disebut sebagai metode rumputan. Ini sudah pernah dengar sebelumnya. Ya, jadi metode-metode itu semuanya itu secara umum bisa kita katakan sebagai metode rumputan. Or in general, we can say that those methods is included in the rumputan method. Yeah. So the rumputan method achieves the accuracy of Taylor series without requiring the calculation of higher derivatives. Yeah. Jadi tidak menghitung langsung derivatif yang lebih tinggi ya, tetapi menggabung-gabungkan, menjumlah-jumlahkan atau meratakan begitu ya, membuat rata-rata menjadi rata-ratanya. Okay. So this is the general equations that we have. So yi plus 1 that can be calculated or that can be projected from the value of yi plus the slope here, which is denoted by phi xi yi h. So phi, the slope here is a function of xi yi or also h multiplied by h, in which p here can be a function, yeah, in the form increment function in the form of a1 k1 plus a2 k2 plus and so on up to an k, in which k here can be a function of x and y, or it can be a function at another point, which is xi plus p1h, in which this will, at this other point here, it will have different y value, or also another point here, 3 or 4 and up to n. So this is another point that we can use in the step size, yeah, in the step size. So this is in the range of the step size. Okay, so that if we have the first order rumputan, so if we have a first order rumputan, so that means we have n value equals to 1. So back here, we have n value equals to 1. It means that this only for the first term. So phi is only include the first term here. So that if we have the second order rumputan, if we have a second order rumputan, it means that we include two terms of phi here. Yeah. So that it means that we include two terms in phi. So a1 k1 plus a1 a2 k2. So this is k2 is a slope at another point here. So that here, if we use a second order rumputan, so we end up with this equation. So k1 is the slope at the first point, the initial point, and p2 is the slope at another point. So this is called the second order rumputan. And we see here that we have the value of a1, a2, p1, and p here, q in the calculations. So that here we can evaluate the calculation here by setting the second order equation to the Taylor series expansion to second order term. Yeah. So that we can find for the value of A1, A2, P1, and P11. Now we will not discuss that on detail, but as a result here, with that calculation, we have this constraint. Yeah? We have this constraint that A1 plus A2 should be equals to 1, and A2 P1 should be equals to half, and A2 P11 that should be P11 that should be equal to half. So that here is the requirement, so that we can insert that here. So for example, if I want to insert the value here, so we have a constraint so that it will satisfy this equation. So A1 plus A2 should be equal to 1. So this is the requirement that we have. And also A2P1, A2P1 here to calculate. So A2P1, that should be equal to half. And also that one, A2P11, A2P11 should be equal to half as well. Yeah, so this is the requirement so that this will satisfy the equation. Yeah, so a value is assumed of one of the unknowns to solve for another three. Yeah, because we have three equations to solve the unknowns. Okay, so that we have to assume one value. For example, we can assume a value of A2. Yeah, so here we choose an infinite number of A2, so that we can yield to a same result to the solution of ODE, which is linear, constant, or quadratic. So we will see here. Yeah. So this is the example. So if we choose A2 value is half, yeah, and with the requirement that A1 plus A2 should be equal to 1, so that means if this is half, so this one is half as well. So that we end up with the Hume's method. Yeah, so this is the Hume's method that we discussed before. So we approximate the value, we predict the value of I plus 1 based on the projection from point yi plus the slope, and the slope is taken as the average of the slope at point 1 and the slope, the average of the slope at point 1 and point 2. Yeah, so that we have log of half of k1 plus half of k2. K1 is the slope taken at the first point, and K2 is the point, the slope taken at the second point, which is obtained from the Euler's method. And this will be multiplied by H. So this is the Euler's method. And if we choose A2 equals to 1, yeah, so that we choose A2 equals to 1, so that we end up with the midpoint method, in which we predict the value of y at I plus 1 from the projection of yi plus k2, the slope at another point at 2 times the set size. And this k2 is taken at x, yeah, equals to half h, yeah, or the midpoint. And yeah, so this is the calculation of k. So we see that it's calculated at xi plus, yeah, xi plus half h. And if we have the Rawson method, so this is another method. We have another method which is called the Rawson method. So the Rawson method is using A2, which is equal to 2/3, to 2/3 of K2. So that means if we have this one is 2/3, so this should be 1/3, so that it will satisfy this equation. So that we have 1/3 of K1 plus 2/3 of K2 times H. So this is the slope. So it gave a weighting of 1/3 of K1 and plus 2/3 of K2. And if we look at K2, where is the position of K2? So this K2 is taken at point xi plus 3/4 of H. So this is the big difference with the midpoint. If the midpoint here, for example, we have xi, we have xi plus 1, so that we have the predicted value is here. So we find the slope here. So we predict you use the Euler's method, to get the value at xi plus half here. And then we use the slope here. So this is the slope that is used here. While in the Rawson method is almost similar, but we will write it here. Yeah, so we have at xi, and for example, we have xi plus 1. So here is taken as 3/4. So if it is half, so this is xi plus 3/4. So here. So what happened? We need to find the value here to project there. And the value here is used to find the slope. So we have two slopes there. We have the first slope, which is K1, and we have the second slope here, which is K2. So this slope is taken at plus 340. So we have K1 and K2 value. Now we give a weighing. So the slope that is used in the Ralston method is predicted from the yi value, projected from the yi value with the slope, which is taken from 1/3 of K1 plus 2/3 of K2. So give more weighing on the second slope, which is closer to the value of xi plus 1. So this is called the Ralston method. Baik. Jadi kita mempelajari satu metode lagi ya. Jadi pada intinya semua digolongkan sebagai metode Rungkuta. Ada metode Rungkuta yang paling sederhana yaitu Euler's method. Kalau kita mau menggunakan order yang lebih tinggi, ya, kalau Euler's method tadi hanya satu persamaan saja di sini, ya, hanya menggunakan satu term ya untuk menghitung slope. Nah kalau second order Rungkuta itu menggunakan dua slope. Ya, jadi menggunakan dua term di dalam perhitungan slope. Nah, tergantung pada nilai yang kita ambil A1, A2-nya berapa. Tapi A1 dan A2 ini punya syarat bahwa harus sama dengan 1. Sehingga kalau kita ambil nilainya tadi adalah A2-nya sama dengan setengah, berarti A1-nya juga sama dengan setengah. Jadi kalau hasilnya semacam ini menjadi Young method. Ya, Young's method. Di mana slope yang digunakan merupakan rata-rata antara titik K1, antara slope 1 yaitu K1 yang diambil pada titik pertama dan K2 yaitu slope yang diambil pada titik kedua. Nah, kalau midpoint method itu menggunakan A2 sama dengan 1. Jadi K1-nya, A1-nya nilainya 0. Ya. A1-nya nilainya 0 yang digunakan langsung K2-nya. K2-nya sama A2-nya sama dengan 1. Jadi tinggal YI plus 1 sama dengan YI ditambah K2 dikalikan 2. Jadi tetap diproyeksi dari YI tetapi menggunakan slope K2. Slope K2 ini di mana? Slope K2 ini adalah slope yang diambil pada midpoint. Ya. Jadi Euler's method tadi digunakan untuk memprediksi poin di tengahnya. Ya. Digunakan untuk memprediksi poin di tengahnya. Nah, poin di tengah ini mencari slope. Slope ini nanti yang digunakan kembali di titik 1, ya, kembali di titik I untuk memproyeksi di titik I plus 1. Gitu. Jadi perbedaannya adalah gimana menggunakan slope-nya ini. Metode yang ketiga yaitu metode Ralston. Metode Ralston ini menggunakan A2-nya adalah 2/3. Jadi diambil slope pada titik yang lain itu diberi bobot 2/3. Slope pada titik pertama diberi 1/3. Nah, titik 2 ini diambil di mana? Ternyata titik 2 ini tidak diambil di midpoint, tetapi diambil lebih dekat ke arah XI plus 1. Ya, yaitu pada 3/4. Jadi posisinya lebih dekat dengan I plus 1. Jadi kalau I plus 1-nya tadi di sini, ya I 3/4-nya, I ditambah 3/4 itu di sini. Ya, tapi tidak di setengah. Kalau setengah tadi kan di sini. Ini diambil di 3/4 tapi diberi bobot lebih tinggi, yaitu 2/3. Jadi pada prinsipnya seperti itu. Ya, jadi mudah dipahami ya. Tapi kalau lihat persamaannya memang bingung ya, banyak tambah, bagi dan sebagainya. Tapi pada prinsipnya mudah dipahami. Baik, ada pertanyaan? Silakan. Ya, jadi itu tadi yang kita pelajari ya. Ini ilustrasinya lagi kita ulang ya. Jadi ini tadi digunakan Young's method ya. Dicari nilai slope 1 dan slope 2, kemudian diratakan. Kita coba lihat ini. Sekarang contohnya kita punya persamaan yang sama dengan tadi, yaitu dy per dx minus 2x pangkat 3 ditambah 12x kuadrat dikurangi dengan 20x plus 8,5. Now we want to find the solution between 0 and 4 with a step size of 0.5. Exactly the same problem that we had before using the Euler's method, but now we are using the Young's method. So this is the Young's method in which the difference with the Euler's method is on the slope. Okay, that using the calculation. So that means that now we need to calculate not only K1, but we need to also to calculate K2, in which K2 is the slope at the second point. So that we will try to do the calculation. Yeah. So that here we need to find the value of K1 and K2. Yeah. So the value of K1 can be calculated directly with minus 2x3 plus 12x squared minus 20x plus 8.5. Yeah. So that we insert the value here. So K1 is taken at the value of x at the initial value. So that will be 0. So K1 will be 8.5. Now we want to calculate x2. So that means this is the slope. Yeah, so if we want to calculate x2, so this will be the slope at the second point. So this is I. So this will be I plus 1. So that we have this slope to predict to another point, which is point I plus 1. So at I plus 1 now, we need to calculate, yeah, so K2 will be equals to minus 2x3 plus 12x, yeah. So now we have to change the value of x now into the value of x, the new x, which is x I plus 1. So this one is initially at x0. So that is x equals to 1. Hold for a moment. Okay, so that we want to calculate for x2 now. Yeah. So to calculate to x2, K2, yeah, to calculate K2, so that we need the value of x here because it's only a function of x. There's no y value. Yeah, so that here we can insert the value of x equals to 1. Yeah, so that will be 1. So 12 times 1 squared minus 20 times 1 plus 8.5. So that will be 1. So minus 2 plus 12 minus 20 plus 8.5. So that we have 10. So that will be minus 10. So that will be minus, yeah. Minus 10 plus 8.5 is minus 1.5. Okay, so that we have the value of K1 and K2 already. So that now we can calculate the new value. So Y at 1.
Itu bukannya 75 ya, Bu?
75. Yang mana ini?
Iya. Minus 2 tambah 12 minus 10.
10.
10 minus 20.
Minus 10.
Minus 10 tambah 85.
8,5.
Oh iya deh, maaf Bu, saya salah.
Ya, betul ya, minus 1,5 ya. Baik. So that we have y1 that will be equals to y0 plus 0.5 times 8.5 minus 1.5 multiplied by h. So h is 0.5. So that we have y value is 1 plus 0.5. So that will be
7 times 0.5. Yeah. So that will be 7 over 4. 7 over 4 is 1.7. So about 2.7. Yeah. Okay. So that is the value. Yeah. So that we have the slope here is 8.5. So K1 is 8.5. The second slope is minus. Yeah. So a little bit down here. So minus K2 is minus 1.5. So the average will be a little bit there, so that it will predict here. So it will be a little bit lower than compared than if you use that one. Yeah. So lower than if you use that one. Yeah. So that the new value which is predicted now using the Hume's method is here. Yeah. Okay, so that is how to perform the calculation, and we can do the same for the another point to the next point, which is x equals 2. Oh, sorry, this is incorrect. Yeah, we have a step size of 0.5, so that should be at 0.5. Yeah. All right, to make it easier, yeah, just say that we have a step size of 1. It will be easier to calculate. Yeah. All right, so that you can calculate to x2, x3, and so on. Yeah. Okay, so this is the basic idea of how to solve using the Hume's method. Any questions? Ya, jadi ini salah ya, tadi harusnya 0,5, tapi kalau 0,5 ini perhitungannya jadi lebih lama ini ya. Nah, jadi yang lebih mudah kita ambil 1, tadi kita anggap aja step size-nya 1 ya. Jadi di sini kita dapatkan nilai akhir ya yang berbeda dengan kalau kita menggunakan Euler. Kalau Euler hanya sudah langsung di sini nilainya, tapi kalau dengan Hume's akan lebih rendah karena slope-nya lebih kecil ya, karena di rata-rata. Okay. Jadi itu dengan Hume's method. Next is using the midpoint method, so that we approximate the value, we project the value using the slope at the midpoint. So the slope that we get from the midpoint, then we change that here. Yeah, when we change, we use the slope at the midpoint to predict from xi. Yeah, so that we have this one. So here you see the slope here, which is K2. So this is K1 and this is K2. So the slope of K2 here, which is used in the calculation. Yeah. Again, with the same problem that we have. Yeah. So we will try to solve, say, to be simple. Yeah. K will be equals to, H equals to 1. So that we now calculate using the midpoint method. Okay, so this should be 0.1, 0.5 as well. Yeah, okay. So that, yeah, again, we still need to, because we need to find the value at the midpoint, so that we have to find, yeah, K1. So we have K1 value, which is equals to minus 2, 0, and so on. Okay. So this is 8.5. So this is K1 value. Now we want to predict to K2. So we want to find the value of K2. Yeah, so if we want to find the value of K2, so K2 is taken at at x equals I plus half of h, because this is at midpoint. So if we use h equals to 1, so that we still to insert the value at 0.5. If we use h is 0.5, so it means half of h will be 0.25. So if we use h equals to 1, we still need to insert the value of 0.5. Yeah, so that we need to insert this value plus 8.5, so that will be equals to a value. And you can calculate that one, K2. And once we have that value, so this will be the slope at the midpoint, so that we can predict yi plus 1, that will be equals to yi plus K2 times h. So the one that is used here, correctly using here, while the value, the slope
of K1 is not used at all in the final calculation. Yeah? So this is just, this is used to predict the value of y. So this is actually to predict the value of yi plus half. But because this value is not needed here, so actually we don't, yeah, we don't need explicitly to calculate that one actually, yeah. Yeah. Okay. So this is to use the midpoint. So you can read this on example 25.6 in the book. Yeah. So this example is taken in the book. As well for the Hume's method, you can see the example as well, the full solution for this in the book. So it's page 705, yeah, example 25.6. And if we use the Rawson method, it means that we need to find the slope at xi 3/4 of h, so it's in here, and we find the slope, so that the final slope will be the calculation of the weighing of 1/3 of K1 is 2/3 of K2. Yeah. So that if we perform the calculation, yeah, so this is the result. Yeah. So this is the analytical result that we have, yeah, the black line. And the Euler's method that we have at first, yeah, with H 0.5. So this in the example is taken at 0.5, yeah, the same H, with the same step size. For Euler, you can see the error is quite large. Yeah, here. And then we have the Hume's method. The Hume's method will be the rectangle sign, yeah, yeah, rectangle symbol, square symbol. This is the Hume method, yeah. And then we have the midpoint method, which is the circle, yeah. And then we have the Rawson method here, which is a triangle. So you can see that for the three of the method here is approximately similar, yeah. So you can see that this is first order and this is second order because it's using two terms to calculate the slope. Now, if we extend further to the third order Runge-Kutta method, it means that we use three equations here. So we have three equations of the slope. So this can be calculated with the slope that is used to predict the value of I plus 1. So this projected from yi plus the slope, yeah, times the step size. So the slope is taken as 1/6 of K1 plus 4/6 or 2/3 of K2 plus 1/6 of K3. And where are these points are taken? Yeah, so where are these points are taken? So we see here that K1 is the slope at the initial point. K2 is the slope at the midpoint. So exactly at half. And K3 is the value at the second point, the second point, or at xe plus h, yeah, plus h, yeah, x equal or xi plus 1, yeah, in which um, this value, so the predicted value at xi plus h is taken from the slope here. Yeah. And we can also find for the fourth order Runge-Kutta equation. So this is for you to know that if we have fourth order, so that we have 4 points, yeah, the slope from four points. The first one is the initial point, the second is at half, the third is also at half, but using the position of y is calculated from the slope at the second, at the midpoint. So here the value of yi is calculated from the midpoint, the slope at the midpoint. And the third one, and K3 is the value of at xi plus 1, which is calculated with K3. Yeah, so the value of K3 here is calculated. So this is for fourth order runtutan. Yeah. So this is we have first order, second order, third order, and fourth order. Yeah. So this is the comparison between those methods. So you can see this in example 25.8 in the book. Yeah. So that we want to calculate the solution from x0 to x4 with the initial condition of y0 equals to 2. And the exact answer of y at 4 at x equals to 4, that will be 75.33896. And the equations to be solved is this one. Yeah. So this is the equations to be solved. Yeah. So that here it's plotted the relative error, the percent relative error. So you can see here that if we have the second order Runkuta is around this one. Yeah, this is the second order Runkuta. This is the Euler's or first order Runkuta. We have the Runkuta of third order will be here, and the fourth order will be here. So you see here that the error is decreasing significantly using higher order method. Yeah, and also we have the Butcher. Now we will not discuss about the Butcher method at the moment. Okay, so that is about the about the method. Yeah, so for the OGE, now we will see again here. Yeah, so we see here that if we want to decrease the error, we can use a higher order Runkuta scheme. Yeah, for the OGE. Ya, silakan kalau ada pertanyaan. Ya, jadi untuk third order maupun fourth order, ya, untuk third order maupun fourth order di sini ya bisa dihitung dengan cara semacam ini. Ya, jadi kebanyakan menggunakan midpoint ya, baik untuk third order maupun fourth order tetap menggunakan midpointnya yaitu untuk menghitung K2 di sini. Ya. Sedangkan K3 itu adalah slope ya, slope yang dihitung dari kalau ini menggunakan kombinasi antara K1 dan K2. Ya. Jadi kalau di sini kita dapatkan ini dihitung dari YI ditambah dengan min 1 ya, min K1 plus 2 K2 ya, dikalikan dengan H. Jadi ini yang digunakan untuk slope-nya ya, untuk menghitung K3. Untuk fourth order juga demikian, hampir sama, tetapi bedanya yang digunakan tetap pada setengah midpoint ya, tetap pada midpoint, tetapi midpointnya dihitung 2 kali. K2 ini dihitung dengan midpoint yang menggunakan K1, proyeksi dari K1. Yang kedua dihitung dari proyeksi K2. Jadi seolah-olah seperti ini. Kalau saya gambarkan, ini katakanlah saya punya KXI, saya punya XI plus 1, ya, maka ini adalah pada XI plus setengah. Jadi nilai midpointnya. Jadi apa yang dilakukan di sini, ini adalah punya nilai, katakanlah ya, initial value, Ini kemudian digunakan untuk memproyeksi nilai di sini. Nah, nilai yang didapatkan di sini kemudian dihitung ya untuk mendapatkan nilai K2. Jadi ini nilai K1, ini K1. Ini nanti kita punya nilai katakanlah K2 di sini. Nah, maka nilai K2 ini ya, nilai K2 ini ya digunakan nilai K2 ini digunakan untuk menghitung lagi. Jadi diperbaiki lagi kemari. Jadi nilai K2 dimasukkan lagi kemari ya dari proyeksi XI untuk memproyeksi dengan K2. Jadi diproyeksi dengan K2 yang dipindahkan ke K1 ini K2. Kira-kira gambarannya ilustrasinya seperti ini. Nah, punya nilai baru di sini ini digunakan untuk mencari K2, K3. Nah, ini misalnya K3 ini K4 ya. Jadi K4, nilai di sini digunakan lagi ini menjadi K3. Nah, misalkan seperti ini K3. Ini digunakan untuk memproyeksi di titik 4. Nah, baru nanti di titik 4 nanti kita punya katakanlah K4. Nah, jadi nanti slope-nya itu adalah K1 yang tadi mula-mula ditambah dengan K2 ditambah dengan K3 ya 2K2 ditambah 2K3 ditambah dengan K4. Jadi prinsipnya seperti itu kan. Jadi menggabung-gabungkan, menjumlah-jumlahkan ya merata-rata slope-slope yang ada di antara dua poin ya, pada poin maupun di antara dua poin tersebut. Sehingga didapatkan keakuratan yang lebih tinggi. Okay, any questions? Okay, so that you can try with example 25.1. Yeah. So here we can solve for the initial value problem over the interval from t equal to 0 to t equals to 2, where the initial value is known, y at value x equal to 0, t equals to 0, that will be equals to 1. Now we have the equations of dy over dt, so this is the slope will be equals to y t squared minus 1.1y. Now be careful with this because we have here the function. Here is a function of y and t, so a function of t and y. So that means we have to calculate the t as well y value, yeah, to approximate, to project the new value at I plus 1. Yeah. Okay, so here we have 4 problems, yeah, we need to do it analytically and using Euler's method with h 0.5 and 0.25, also using midpoint method with h 0.5 or fourth order Runkuta method with h 0.5. Okay, so yeah, you can try this. Yeah, you can try on this. Okay, so this will be an assignment, yeah, for next week. Yeah, so this will be an assignment for next week. So we have 2 tasks. Yeah, if you want to resubmit the midterm exam that will be due tomorrow, and this is for next week. Yeah, due to next week to solve for this one. Yeah, 25.1. Okay, any questions?
Iya, Bu. Ini, Bu.
Ya.
Saya, Bu.
Ya, silakan
Ini, Bu, tadi pagi kan ini sih di luar materi kuliah, Bu. Cuma saya mau memberitahukan, tadi pagi saya ada masalah di akun MyITS saya, jadi saya sudah WA ke Ibu yang lebih detailnya. Jadi saya masuk ini lewat Zoom link yang dikirimin teman, Bu.
Oh, gitu ya. Iya.
Untuk absen, saya enggak bisa absen jadinya, Bu, sama sekali.
Ya. Ya, enggak apa-apa. Nanti saya masukkan ya. Ini siapa ini? Siapa aja yang belum absen ini?
Rizali Ahmadan, Bu.
Ya.
Saya.
Ya, makasih Bu.
Iya, enggak bisa masuk classroom ya, enggak bisa masuk classroom.
Yonas Ibu ya.
Nggak bisa
Ya,
Bu.
oke Yonas.
Saya sudah foto kan saya WA Ibu tadi pagi jam
Oke.
8 lebih 1 menit. Kalau di waktu saya Bu, di waktu saya. Kalau di Ibu jam 7 lebih 1 menit.
Oh ya, mungkin saya belum melihat. Ya, itu diurus ya mungkin ya. Apa nggak bisa masuk sama sekali mungkin kalau diurus ya. Karena
Udah
ada.
diurus Bu, masih diproses.
Oh, masih diproses.
Masih diproses sama ya.
Tapi sudah diurus ke Pak Bambang sudah ya?
Sudah Bu, sudah.
Oh ya sudah. Karena memang ada beberapa akun yang problem ya di Classroom. Ya, yang kesulitan untuk upload, misalkan besok belum beres, misalkan mau upload ya misalkan di email aja ya. Cuma saya ya.
Iya Bu, terima kasih Bu.
Di email aja mungkin biar ada recordnya. Kalau WA kadang ketumpuk ya. Kadang-kadang ketumpuk. Jadi lebih baik di email record gitu. Kalau misalkan ada kesulitan, kalau tidak ada ya tetap langsung masuk classroom ya supaya lebih mudah evaluasinya. Oke, baik. Ya, mungkin itu. Any other questions? Okay, so yeah, yeah, Jonas.
Yeah, today I didn't feel the attendance because of my connection is not unstable today. That's why.
Okay, yeah, all right. I will click on your absent list. Okay.
Okay, well.
Yeah.
Thank you.
Yeah, all right. Ada lagi Fatin mau bertanya?
Ya Bu, untuk mata kuliah ini tuh apa kita juga diajari cara menghitung tapi melewat software Bu? Bukan manual aja Pak? Emang cuma manual pakai perhitungan tangan?
Iya, ya sudah. Ya, memang tidak proporsinya tidak banyak ya, tapi paling nggak kita sudah mempelajari caranya. Jadi pekan lalu sudah saya tunjukkan juga ya, 2 pekan yang lalu ya. Kapan? Waktu kita belajar matriks ya. Nah, waktu belajar matriks itu ada cara menggunakan MATLAB. Ya, tetapi memang tidak porsinya tidak besar ya. Sekedar menunjukkan bahwa software itu menggunakan metode yang sudah kita pelajari. Ya, jadi metode itu menggunakan metode yang sudah kita pelajari, termasuk juga di Excel ya. Jadi sebenarnya sudah saya tunjukkan caranya ya, menyelesaikan matriks dengan Excel langsung memang keluar hasilnya begitu ya. Nah, tetapi kan tidak istilahnya langsung hasil akhir seperti itu ya. Jadi memang di sini kita gabungan ya. Ada sedikit coding yang saya tunjukkan tadi ya dengan MATLAB tadi contohnya bagaimana kita memasukkan suatu kode prosedur atau instruksi ya tahapan-tahapan penyelesaian di dalam MATLAB. Ya, tetapi memang kita tidak fokus ke situ, ya, tidak fokus itu. Nanti tetap ada di dalam bentuk tugas, ya. Jadi dalam bentuk tugas. Jadi kalau memang kita mau mencakup semua itu tidak selesai ya. Kalau misalnya semuanya dibahas secara detail termasuk juga menggunakan MATLAB itu nanti nggak selesai. Jadi memang lebih banyak mandiri untuk MATLAB-nya karena memang materi kita juga banyak gitu ya. Jadi ini saya tunjukkan aja. Termasuk juga di MATLAB kemarin sudah saya tunjukkan ya ada mendapatkan LU bagaimana ya, mendapatkan menggunakan LU di composition itu bisa langsung muncul ada fungsi-fungsinya di dalam MATLAB. Jadi tinggal dimasukkan koefisiennya, nanti bisa dapat LU matriksnya seperti itu. Nah nanti lebih ke mandiri. Nanti insya Allah rencananya nanti akan ada assignment ya menggunakan MATLAB gitu ya. Jadi nanti kalau MATLAB itu sudah tinggal panggil fungsi aja ya. Sebetulnya MATLAB itu sudah panggil fungsi. Nah, jadi tinggal memanggil fungsinya saja. Jadi memang kita tidak membahas terlalu detail di situ, ya, hanya untuk menunjukkan bahwa function yang ada di semua pemrograman itu basisnya adalah dari metode numerik. Ya mungkin gitu ya Fatin.
Baik Bu, terima kasih Bu.
Ya. Ya karena memang kalau mau membahas secara detail nanti banyak sekali waktunya ya. Harapan saya memang sudah ada basic-basic programming, komputer programming, walaupun tidak dalam, ya. Paling enggak sudah ada basic komputer programming seperti itu. Nah nanti lebih banyak ke belajar mandiri ya. Nanti kalaupun programming pun tidak ya tidak tinggal panggil aja, sebetulnya seperti itu. Jadi lebih mudah. Ya. Makanya di sini kita harapannya kalau tugas ataupun ujian ya, jadi mungkin seperti itu ya. Baik, ya, saya rasa itu ya saya akhiri untuk pertemuan hari ini. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Bu.
Terima kasih Bu.